Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is rational function differentiation. So let us see how to differentiate any rational function which has a numerator and denominator. Here is the rule we apply when we are going to differentiate rational function. This is called Quotient Rule. This is a formal rule for differentiating problems where one function is divided by another. Okay, it also follows from the limit definition of the derivative. So derivative of any rational function, numerator over denominator, is equal to denominator times derivative of the numerator minus numerator times denominator's derivative divided by denominator the whole square. So remember the rule in the following way. Always start with the bottom function and end with the bottom function squared. So note that the numerator of the quotient rule is identical to the ordinary product rule, except that subtraction replaces by addition. So in the list of the problem that we are going to discuss in this video, most problems are average and a few are somewhat challenging. Okay. First, let's start with the proof of the rule. Suppose f and g are differentiable and this is a function. It can be any function s of x, f of x over g of x. Suppose these two are differentiable, then from the definition of the derivative, limit h tends to 0, s of x plus h minus s of x over h. So now let's apply this term for the assumption we took. So s of x can be replaced by f of x over g of x. Just replace x by x plus h. So you'll get a term for this one. So let's plug in that too. As we generally do the cross multiplication for fractional subtraction. Multiply the first term with the denominator of second term. Multiply the second term with the denominator of first term and make the denominators common. Hope you remember fractional subtraction. Now the common denominator and keep the terms in the numerator. We are just going to do fractional division here. So this denominator will be shifted here. Let us add and subtract f of x, g of x in between. Let me group the like terms. So we get, hope you are clear with this step. Now I'm just going to take this h as a denominator for both the terms separately. So I could rewrite it by applying the limit. Hope you can follow so far. Now apply the limit. If h tends to 0 in the denominator, this would also become g of x. So g of x times g of x is g of x square. And in the numerator part, if you're taking this limit to this term and limit to this term, because limit is common for both the terms. If you're taking it within this, that's it for this proof. Please have a glance over each and every step and let me know if there is any query. We are just starting with the function s of x and this is the definition of the derivative. Here we are just applying the function for s of x and s of x plus h, and then we are just doing fractional subtraction and then taking the common denominator and doing fractional division. After the fractional division step, I'm just adding and subtracting the product f of x, g of x, so that we can group and take the limit within and give the required result. Hope you're clear with the proof. Okay, now let us move on to some examples. Here is an example. We are supposed to find the differentiation of this rational function. In this question, we have a numerator and denominator. So let us directly apply the quotient rule. Here is the formula. So just plug in the corrective place, respective place. So g of x here is the denominator 5x minus 1, f dash of x. Okay, let me write it. I have just plugged in f of x and g of x, the numerator and denominator in the respective places. Now let's find the derivative of this. Derivative of 4x plus 1 is nothing but derivative of 4x plus derivative of 1. Derivative of the constant is 0. So derivative of this one is a constant multiple. So take this constant out and find the derivative of x. So you will be getting 4 here. Am I right? Same way, derivative of 5x minus 1 is 5. Okay, let's plug in those values here. Now all you have to do is just open this parenthesis by distribution and then combine all the like terms. Combining the like terms we get, hope you're clear with this example. Okay, let me take one example with a constant in the numerator and an expression in the denominator. Here is the example. Let's apply the formula. So write the denominator, multiply the derivative of the numerator. Derivative of numerator is just a constant, so 0. Minus sign in between. Keep the numerator as it is. Multiply by the derivative of the denominator. Derivative of denominator is just 1. Square the denominator. Now let's simplify 0 times anything is 0. So this term itself becomes 0. Minus 2 times 1. So 0 minus 2 is negative 2. That's it for this problem. Hope you're clear with this one. Okay, now let me take one more example with some trigonometric terms. Let's see how we are going to apply rational rule, the quotient rule here. Here is the example. Please have a glance over this question. Let me include one coefficient here. Okay, we have two functions, one in the numerator and one in the denominator. Let's apply quotient rule to find y dash. Hope you're clear with this step. I have just plugged in the terms in the respective places in the quotient rule. Now we are going to find the derivative of these terms. Derivative of 4 sin x. Take 4 outside and find the derivative of sin x. Derivative of sin x is just cos x. Am I right? Now let's find the derivative of 2x plus cos x. Derivative of 2x is just 2 and derivative of cos x is minus sin x. Plug in correct signs. Since we have parentheses, we are going to distribute. 2x times 4 cos x plus cos x times 4 cos x minus 4 sin x times 2 minus minus plus. So 4 sin x times sin x. Now I wanted to use the trigonometric identity cos square x plus sin square x is equal to 1. So I'm going to group these two terms separately and group these two terms separately. Reason behind this is we want a simplified answer. That's the reason. We can simplify as much as possible. Once you're doing all these steps, you have to check whether any trigonometric identity is possible to use here. If yes, you can just group the like terms, the terms that could be termed into a trigonometric identity, and then use that identity to simplify and give your answer. Replace cos square x plus sin square x is equal to 1. That is a trigonometric identity. So after replacing, we will get our final answer. That's it for this problem. So whenever you're dealing with trigonometric problems in quotient rule, applying the quotient rule differentiation, you have to think whether any trigonometric identity is possible. If it is possible, you can just use that identity to simplify your answer. Otherwise, your answer will be considered as an incomplete one. So think well before you end the question. Always try to give a complete answer for your solutions. Hope you're clear with this example. Concept is very simple. You're going to apply the same concept. Only thing is the algebraic calculation, trigonometric identities would be somewhat different when compared to the other problems. Now let us take one example which is involving exponential function. Here is the example. Let's apply the quotient rule here. Same rule again and again. I'm always starting with the denominator, negative sign in between, and I'm going to end with the square of the denominator. After plugging in all the terms in the respective places in the quotient rule, now we are supposed to find the derivative of the terms which needed to be. Hope you're clear with this step. Now distribute. Derivative of this exponential function is itself. Derivative of e raised to x is e raised to x. That's it for this problem. Please check whether you're getting the same explanation, same result if you're simplifying this. Hope you're clear with finding the derivative, applying quotient rule for the exponential function. Okay. Let us take one example with natural logarithm and let's see how this quotient rule is applicable in that problem. Here is the example. So let's just apply the quotient rule and then we can find the derivative and then simplify the terms and combine all the like terms to give the final answer. So here we have a numerator and denominator as usual. Let's apply the formula. Always start with the denominator, minus sign in between, end with the square of the denominator. Now let's find the derivative of 1 plus ln x. Derivative of 1 is 0. Derivative of ln x is 1 over x. Am I right? Same way, derivative of x square is 2x. When you just split it, it will be very easy for you to find the derivative. So don't get confused just by looking at the question. The derivative of ln of x is 1 over x. So please always be careful with the signs. Now you can distribute. Group all the natural logs and combine the like terms wherever possible. After distribution, we get this. Now let us combine all the like terms. So this will get cancelled out with this one. 1 over x will be the first term. X minus 2x. So negative x would be the second term. And 2x ln x would be the third term. I just wanted to keep a positive term as the first term. Instead all the negative terms. No problem even if you write the x as the first term. There is nothing wrong with that. So I just wanted to want this answer to look pretty. Okay. Hope you're clear with this example. You can also simplify this one, multiplying each and every term throughout in the numerator by x and denominator. You can do fractional division here and simplify your answer further. That's it for this example. Okay. We have discussed various cases, various types of examples. Finally, let us discuss one example with base as a number and exponent as a variable. Please consider this example. We have a numerator and denominator. Let's first apply the quotient rule and then let's look at the differentiation part. I would like to recall that derivative of a raised to x is nothing but a raised to x ln a. Let's apply this rule here even for these terms because we are going to find the derivative of each and every term separately. Hope you're clear with this step. Now distribution. You have to multiply the term outside the parenthesis with each and every term within the parenthesis. So after combining, you also have to be familiar with laws of indices, because if you're going to add or multiply any bases with the same exponent or same bases with some exponent, you have to apply that laws. So after applying those laws, hope you're getting the same expression. Okay, even here you can apply one more law. Ln of a minus ln of b can be written as ln of a divided by b. Am I right? So let's use that law here. That's it for this example. Hope you're clear with all the examples we discussed in this video. We discussed different cases, different types of questions. And we are applying the same formula, same concept. Only thing is the terms are different, so we are applying respective rules then and there. Okay, in case if you have any query regarding